This is lesson 2 for the makeup work in functions in Algebra 1A. Here we're going to learn how to graph equations. Our objectives, we're going to continue to evaluate two variable equations like we did in lesson 1, but now we're doing it with the goal of building a table. We want to identify ordered pairs of an equation, and we want to graph an equation by building a table. These three skills are connected because ordered pairs for an equation are the same thing as the solutions. And we see that in the definition. An ordered pair is a solution to a two-variable equation. It also points to a specific location on a graph. It is a point. We write those as an ordered pair x, comma, y. A solution are the numbers that make an equation true. So x and y together would make the equation true. We show that with a point on the graph. Again, our big objective here is to graph an equation by building a table. To build that table, we need to evaluate an equation. We do that by picking different values of x. If we do that, we can use them to find y. We could pick any values for x, but oftentimes we use the same 5 numbers, -2, -1, 0, 1, and 2. We like those numbers because it's right in the middle of our coordinate grid. We use some negative numbers and some positive numbers. But again, anything can work. Taken together, x and y are solutions. If an equation has two variables, if it has an x and a y, it actually has many solutions. It has infinite solutions even. There's so many different pairs that can work. We represent that as ordered pairs, right? The solutions for a two-variable equation are written as ordered pairs. Let's take a look at how to build a table. We're going to evaluate the function for different values of x to build these tables. Then we're going to write those solutions as ordered pairs. So first, we need to remember we picked some numbers for x here. I said some numbers work better than others. Let's go ahead and use these same 5 numbers from above to evaluate x. So we're going to have -2, -1, 0, 1, and 2. When we have these values of x, we have to substitute or replace those values in the equation. So for number 1, we're going to have y equals -2, because we're replacing that x with the x value, plus 5. If you're using your school computer, you should have the calculator app built in. What you need to know is you're going to push 2 first, then you're going to push negative. So you have to press this +/- button after the number, add 5. There we go. We're going to get 3. So there's our y value. Let's do it again with -1. So we have y equals x is -1. And then we add 5. I'm going to show you one more time how to do that with the calculator. So we put 1, then the negative sign, plus 5, and we get 4. You can always use your phone for this. I have different calculators in class, but I want you to have this resource handy just in case. Let's evaluate these other ones. So again, we're just taking these values for x and putting them in the equation. Y equals 0 plus 5. It's always going to be plus 5. Y equals something plus 5. That's all that's happening to the x up there. It just says x plus 5. So I'm going to write all of those first. This would be 0 plus 5, 1 plus 5, and 2 plus 5. You don't have to write this substitution step out. This part here in the middle is definitely optional. When you get proficient evaluating a table, you're not going to write all those steps out. You're going to plug and chug with your calculator. But for now, I'm going to show you that substitution step and encourage you to write that down so that you can see exactly what to put in your calculator. 0 plus 5 would be 5, 1 plus 5 is 6, 2 plus 5 is 7. All we have to do now is write those as ordered pairs. Ordered pairs use the x and the y coordinate. So we're going to take the x and the y, and we're going to put them together. This first row would give us negative 2, 3. This would give us negative 1, 4. Middle row is 0, 5. 1, 6. 2, 7. That equation was pretty easy to evaluate. Let's take a look at the second example. Here we have y equals negative 2x plus 3. We want to look at that equation and remember what this is telling us. It is telling us we're going to do negative 2 times x plus 3. And if we think back to our order of operations, we know that we want to multiply before we add. Let's go ahead and set up our table. We need to pick some values for x. You can pick whichever numbers you like. I'm going to use the tried and true negative 2, negative 1, 0, 1, and 2. I'm not going to write out the substitution for every row, but I'll write it out for the first few here. The equation is y equals negative 2. It's a negative 2x, so this would be negative 2 times negative 2 plus 3. I'll demonstrate how to plug that in your calculator. Both of these are negative, so make sure you're paying attention to that. We have negative 2, so I hit the number, then the sign, times negative 2. That gets me a positive 4. You can always look up here and check your work. I did a negative 2 times a negative 2. This calculator shows me that. You can also check the memory here at the top. It shows the same answer. Don't forget to add 3 after you multiply, because we're doing all steps in the equation. When we add 3, we're going to get 7. Next example, y equals negative 2. This time x is going to be negative 1. Then we're going to add 3. You might notice it's kind of hard to see when there's two signs here. So another idea would be that you can just use these parentheses around negative numbers, or you could do negative 2 parentheses negative 2, because again, we don't have to write that multiplication sign there if there's parentheses. Let's do 2 negative times 1 negative plus 3, and we're going to get 5. I'll set up one more, and then I'm going to complete the rest of these quickly just to save time for you all. Here we'd have negative 2 times 0 plus 3. Again, it's always negative 2 times something plus 3. So negative 2 times 0, negative 2 times 1, negative 2 times 2, plus 3 plus 3 plus 3. 0 times negative 2 is going to be 3, so this one is going to be 3. Negative 2 times 1 is negative 2. When we add 3, we get a positive 1. And then the last one is a negative 1. Writing these as ordered pairs, we take the x and the y, and we put those together. So we have negative 2, 7. Negative 1, 5. 0, 3. 1, 1. Oops. And then 2, negative 1. I'll stop this video here. go ahead and complete this table as a check-in and send a picture to Mr. Bechtel. In the second part of these notes, we'll learn how to graph these ordered pairs, and you will actually, let's go ahead and do that now. So now that you've completed these check-in problems, go ahead. Now that we've gotten these ordered pairs, how about we go ahead and do a check-in where you all complete these two tables here. When you finish those, you can take a picture and send it to Mr. Bechtel. So ordered pairs, I said earlier, can be used to make a graph. We built these tables with the idea that we'd be able to make a graph with it. Ordered pairs represent solutions to equations. We wrote that a lot on the front side of our notes. But they also point to a location on a graph. A graph can refer to a line for an equation, or it could refer to the coordinate grid. For the most part, when I say graph, you should be thinking the points or the lines for an equation. This coordinate grid we see here can sometimes be called a graph or often graph paper, but is really just our workspace for a particular equation. A coordinate grid has an x-axis that goes horizontally. So this right here is the x-axis. And it has a y-axis, which goes vertical. It goes up and down. So when I look at an ordered pair, this tells me how far left and right to go with the x coordinate, and then how far up or down to go. And with that combination, if I know how far right to go and how far down, or how far left and how far up, I can end up anywhere on this graph. I'm going to erase those lines, but we can always remember that the red is horizontal, the green is vertical. Let's start with the point 2, 1. I'm going to graph this one in black. The 2 is positive, so we're going to go to 2 on the x-axis. 1, 2. Then we look at the y-coordinate of 1. That tells us we're going to go up 1 on the y-axis. Again, this matches up with the 1 there. So this is our point for number 1, 2, 1. Let's do this next point, 5, 3. So again, the 5 is our x-coordinate. That tells us side to side. If I start here at the middle, because that's 0, I would go right to the 5. Now I look at the y-coordinate, which is 3. I could look at the y-axis and find that 3, but it needs to have a y-coordinate of 3 and an x-coordinate of 5, so I think it's easier to just go up 1, 2, 3. This is going to be the point 5, 3. I will do the next 2 points, and everything after this is going to be a check-in for you. So this point is negative 1, 2. Again, the x-coordinate goes first. If I start in the middle, negative 1 is going to be right here on the x-axis. Next, the y-coordinate is 2. That tells me to go vertically, tells me to go up 2. Last example, 4, negative 4. X-coordinate of 4 goes first, so I go over 4. Here the y-coordinate is negative 4. We haven't seen a negative y-coordinate yet, but we see that is down here. So if I again start in the middle, 4, negative 4 brings me to this location. For the remainder of these notes, I want you to put the rest of these points on the graph and use the skills we learned above where we completed the table and wrote those ordered pairs, along with our graphing skills here to graph this equation. You're going to start by completing the table I'll go ahead and tell you which x values to use. You're going to use -2, -1, 0, 1, and 2. Don't forget to write your answers as ordered pairs over here. And then you're going to use those ordered pairs on the graph. So again, complete the table, write the solutions as ordered pairs, and then graph those solutions. When you finish this, take a picture and send it to Mr. Bechtel.